Hello friends, welcome back to my channel Chemistry with TV. So in this video we are going to discuss as to why Fe2 plus and Fe3 plus, both complex ions, react differently with sodium carbonate. First of all, let's look at the hexaequaferrate 3 plus, that is Fe3 plus aqueous ions. You know that this exists in the form of an octahedral and with 6 water ligands, and each of the water ligand uses the lone pair on oxygen to form a dative covalent bond with the Fe3 plus. The overall charge is 3 plus here. Now you can see that Fe3 plus has a much greater charge density as compared to Fe2 plus. As a result of this, it's able to polarize some of the water ligands, and it attracts these water ligands so strongly that some of the OH bonds break. And when these OH bonds break, then obviously what will happen is that the H plus ions would be released in solution. And if we were to write this as in an equation form, then the product is going to be Fe. Let's say if only one water ligand had broken, then 5 water ligands left and 1 OH. Now Fe was 3 plus and this is 1 minus, so therefore overall charge will be 2 plus. So you will get this aqueous solution, and these H plus ions are going to make this solution behave as an acid. These are the notes for this one. Now these H plus ions which are released from the Fe3 plus, those are going to be reacting with the carbonate ion in a typical reaction of an acid with carbonates, releasing carbon dioxide and water. Now if we were to look at this reaction for the Fe H2O6 3 plus with carbonate ions, then what you would see is that when water ligands break, then the H plus ions released are going to react with the carbonate ions, and the hydroxide ions that will be left, they would be reacting in a precipitation reaction to form a brown precipitate of iron hydroxide. This will be a solid brown precipitate, and there would be carbon dioxide would be released and water. In order to balance this, we'll have 2 of these, and 3 carbonate ions will give you 3 carbon dioxide and 3 water. So you can see that the observations when you add sodium carbonate to a Fe3 plus aqueous complex, then in that case the first observation would be that the solution, which was yellow in color, will give you a brown precipitate, and the second observation would be that some gas bubbles would be seen, and the gas, if you pass it through lime water, it would make it turn cloudy. Now let's look at what happens in case of Fe2 plus complex ions. Now Fe2 plus have a much lower charge density as compared to Fe3 plus, and as a result they are not able to polarize the water ligands to as much extent as the Fe3 plus ions, so obviously the solution will not be acidic in nature. So therefore when you add these carbonate ions or sodium carbonate to a solution of Fe2 plus, then in that case it will be just a precipitation reaction, and you would see a carbonate precipitate FeCO3. So you can see that the observation when you add same sodium carbonate to an Fe2 plus aqueous, then in that case only observation will be that you would see a blue-green precipitate of iron carbonate and no gas bubbles would be seen. Now mind you that the same reaction that we have just discussed about the Fe3 plus ions, the same reaction would prevail whichever transition metal you are looking at. If it is in a 3 plus form, then the solution is going to be acidic, and therefore with sodium carbonate it's going to give you a hydroxide precipitate and carbon dioxide would be released. For example, if it were Al3 plus or Cr3 plus or any other transition metal which exists in a 3 plus state, you would be able to see a precipitate and carbon dioxide gas bubbles. I hope this explanation was useful for you, and if you like this, then please like, share and subscribe. Thanks for watching. Bye.